Pop quiz. For a reaction at constant temperature, if Q is less than K, what happens? A. It shifts left. B. It is already at equilibrium. C. It shifts right. Lock in your answer. We will reveal it in a moment. Here is a twist. The equilibrium constant tells you the yield at equilibrium, not the speed. Two very different starting mixtures can end at the same equilibrium because K is the target. Q tells you where you are right now. In this video, you will learn what the equilibrium constant K and the reaction quotient Q mean, how to compare them, and how to predict the direction a system will move to reach equilibrium. First, the big idea. K is the equilibrium constant. It uses equilibrium concentrations, and at a fixed temperature, it is constant for a given reaction. Q has the same form as K, but you plug in the current concentrations. Only at equilibrium does Q equal K. Comparing Q to K gives direction. If Q is smaller than K, there are more reactants than products, so the forward reaction is favored. If Q equals K, the system is at equilibrium. If Q is greater than K, there are more products than reactants, so the reverse reaction is favored. Let's try numbers. For 2A in equilibrium with B, K sub C equals 50. The concentration of A is 0.10 molar, and the concentration of B is 0.20 molar. Q sub C equals B divided by A squared, which is 20. Since Q is smaller than K, the system will shift to the right, favoring the products and the forward reaction. Time to reveal the pop quiz answer. If Q is smaller than K, the system shifts right. That is option C. A few quick fixes. First, K does not change when you change concentrations. It depends on temperature. Second, K does not tell you how fast a reaction reaches equilibrium. Third, when writing K or Q, you omit pure solids and pure liquids. Only gases and solutes are shown. So far, you can define K and Q, compute Q from a snapshot, compare it to K, and predict which way the system moves. Think you've got it down? Head over to this link for a practice test and join the study streak, or stick around to learn more about the topic. Let's change the stoichiometry. For A in equilibrium with 2B, K sub C is 0.010, with A at a concentration of 0.30 molar, and B at a concentration of 0.10 molar. Q sub C equals B squared over A. The obtained result of Q sub C is 0.033. Since Q is greater than K, the mixture will shift left, favoring the reverse reaction and the reactants until Q equals K. What if you start with only products? Conceptually, Q is huge, so the system shifts left. In practice, avoid dividing by zero. Treat absent species as very small, not exactly zero, or work with partial pressures and moles. No matter the starting point, reactants, products, or a mix, the system moves toward equilibrium. Try this recipe on any problem. 1. Write the balanced equation. 2. Write the K expression. 3. Plug in the current concentrations or partial pressures to get Q. 4. Compare Q and K and draw the direction arrow. That arrow tells you which reaction is favored until equilibrium is reached. To recap, K fixes the target ratio at a given temperature. Q measures the current ratio. If Q is less than K, shift right. If Q equals K, you are at equilibrium. If Q is greater than K, shift left. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.